Hi everyone, welcome back to the second lecture of the course Engineering Drawing. So, in this session, let us learn types of lines used in engineering drawing. So, when I am taking this cuboid and placing it in this position, you observe from your when you're watching like this, you are able to visit this edge, this edge, this edge, this edge, this edge, this one and this one. But behind there are one edge vertical ones and other two horizontal ones backside. Front side two you are able to visit, but backside there are again two. Those are not visible to you. So in drawing, how we draw these edges which are visible and those edges which are not visible. Say this is the cuboid you have. General method is to draw like this. But that is actually in engineering drawing perspective it is wrong. Why? Because from front when you view, you are able to view this line, this edge, this edge, and this edge, this edge, and this edge. You are unable to visible this backside lines. So when you are so drawing having a particular diagram whose visible edges are drawn, then that we call it as an outline. So these dotted lines or these dashes, lines represented by these dashes, they represent hidden edges. So these thick edges represent outline. These lines, the lines use it to represent visible edges. Those lines we call as outline. Now coming to the next one, margin. Actually, this margin comes in a chart paper. Say, actually by standards we have A0, A1, A2, A3, those papers. Now in that for suppose say A1 we have 594 into 841 mm. So this is the chart. Standard charts. This is 594 mm. This is 841 mm length. So this is A1 chart. Now in that the raw charts are not trimmed to this size. They are bigger than that, a little bit bigger, not very much, a little bit bigger than that. Means we call them untrimmed charts. Untrimmed charts. Now in the untrimmed charts, when we print this border is exact size of 594 by 841, this thing, this these lines we call at marginal. These are thick lines, thick and continuous. So after we trim this, we get the exact size of the chart or exact A2 size, A1 size. Sorry. Those we call as margins. Inside that comes borders. That I didn't write here. That will come in the next one. So borders. In the borderline, now only I will discuss borderline as well. I will finish that as well. Anyway, sixth one, borderlines. So border lines, coming to border lines, say in the given chart, I have shown you the picture in the previous class itself. Say in that while drawing a particular in the way for a given chart, if you have exact dimension, exact shape, it's fine. In that, from this, from this end and this end, from these three ends, we draw lines parallel to these edges at 20 mm gap. 20 mm gap. This will be 20 mm gap. A distance of 20 mm. Now, But from here we will leave 40, 20, somewhere between 20 to 40, say 30 mm, and we will draw. So this is also thick line only, continuous. So this inside one we call it as border line. This outside one we call it as a margin line. Now why we are leaving this much space? And in any drawing we draw, we will be drawing in this space only. Within there we have a title block, which will mention several values or specify certain things. Say who is drawing it, what is the name of the firm or college, why, which drawing, what does this represent, what are the dimensions, say all are in mm or meters or centimeters, first angle projection or second angle projections, drawing number, revision number, those all details will be there in this title block. So that says everything about what is this drawing about, who is giving it, who has verified it, all those things will be there in the title block. In within this region, we will draw our diagrams. Say it is of cube, or say it is of certain three-dimensional object or something, anything. Say it is a hexagonal bolt or whatever it is, we will draw in this space. So this is the thing we have. Now why we have this much gap, this why we are leaving this much space here? Here we are leaving only 20 mm, but here we are leaving about 30 mm, 20, in between 20 to 40. The reason is sometimes, say this is a A4 sheet or A3 size, we will have some hundreds. Any industry will have some hundreds of drawings. So they will categorize them, put some together. Each category they will put together. Say there are 100 drawings. Those 100 drawings they want to put together. They will bind it. When they bind it, either it is a spiral bind or some clipping or pinning, whatever it is, they place one on it and they will bind it. When they are binding it, there should be some space. Should be in a position to open one by one and look at each other. If we don't leave that much space, what happens? It will become clumsy. It won't open when we bind it. It won't open completely, and some part of the drawing will go into the binding. So to avoid that, to have clear picture of the drawing completely, we will leave some extra space on the left edge. That is the reason why we have to leave more space here. So those are border and margin lines explained. Now next is dimension line. Say for suppose I have certain object. I have certain object. I have certain object. I don't assume what it is. Relieve it. So anyway, this is certain object I have with a certain hole. I'm looking like this. This is certain view. I'm having this look from this side. When I draw some orthographic positions from up and down. What are orthographic projections? We will learn later. Anyway, we will have, say, from top view when we draw, we will have something like this. We will have something like that. So these will have dimensions, right? So these are thick lines, these are outlines which are clearly visible. So this will be thick and continuous. Now I want to have dimensions. What is the length of this? What is the length of this? What is the width of this? All those things. So we'll have at a little bit distance away from this, at a little, very little away, we'll have certain thin lines. Thin lines. So between those, one more line we can have. Now, one more thin line when we have it horizontally, ending with arrowheads. This is the arrowhead I'm talking about. This is, for example, say line. This is the arrowhead. Arrowheads can be of different shapes. This is one of the shape. This is another kind of shape. So I will be using this one, and I have one more line. this. So these are thin lines. These are thin lines. Thin continuous. These are thick lines. These are outlines. These are thin lines. We call these lines which are representing the length of this particular element. This one is representing length of this particular element, that we call as dimension line. These we call a dimension line. And these dimension line are enclosed by these particular lines. We call these as extension lines. These both are thin, continuous. Thin and continuous. So outline is thick and continuous. It represents visible edges of the drawing. Margin and border lines I have anyway said. Now hatching and section line. What is that? And remember one more rule. To draw this dimension line, there have minimum distance between this and edge and this dimension line level. Minimum should be 8 mm. It is recommended. I am not saying exactly this has to be followed, but it is recommended to have at least 8 mm gap between the last visible edge and dimension line. Subsequently, every dimension line should be at least, it can be more, but at least it should be of 8 mm gap. Now that is one of the rules I wanted to say. Anyway, one more thing, you might be asking me, you have given dimension for this, say it is 50 mm or whatever it is, and this is say 70. Now you are basically, why I am not representing this? So in drawing, everything should be stated, but that doesn't mean we can state same thing 2 times. When I'm drawing 50 here and I am stating 50 here, this length, and total length is 70, automatically this is 20. Indirectly I am stating that this particular thing is 20 mm width. So again, after in spite of stating 50 and 70, again in addition I draw 20, then this becomes redundant. So whether you are stating it directly or indirectly, once you have stated something or represented something in the drawing, don't represent the same thing again. So we no need to represent 20 again. Just write 50 and 70. For this diagram, that is enough. So while drawing and giving dimensioning, you should have proper knowledge whether every element is specified or not. So directly or indirectly, you have to specify everything, and you should not repeat the same thing again. Both things you have to balance or understand, keep in mind. So these are few lines. Now next one is hatching or section line. Say I have this marker, I am cutting this. When I cut open, I want to see what is inside. So when I cut open, this is a marker, so it will be a hollow part, a certain thickness, and inside it there will be a refill. Now, how can we know whether it is a concentric circle or it is a section? Then we have to hatch it. So what happens? Outer shell of this marker is of negligible thickness, like this. Inside it there will be refill with sponge. It will be filled. We have to show like that. Now that is a clumsy one I have shown, but a very proper way of showing is, say for example, there is a rectangular bar. Now what I want, at this position I want to break it and check what is the cross section there, how it is there, or what kind of cross section we have there at this particular plane. Now when I check it, break it and take apart, have a look at it, this will be the cross section. Now how to say that this is the cross section, this is representing a cross section? We can say that when we draw certain hatching or section lines, these section lines, I will draw a bigger one. So these section lines, so this is the outline of the diagram. Now in that particular section, to say that this is representing a section, we have to draw section lines or hatching lines. These hatching lines are generally at 45 degree with respect to horizontal and at a gap of 1 to 2 mm. That is all about hatching lines. So they are used to represent uh, sections of any given solid or hollow, whatever it is, given the three-dimensional object. Now coming to next set of lines, leader or pointer line. So where do we use this? Say for example, we have certain plate with a hole here, or punch, whatever you say, or a blank, whatever you call it. There are different names. Anyway, so for this particular hole, this will have certain diameter. So how to represent it? It is very small. If we draw inside and we place the dimensions, it will be clumsy. So what alternative we have is, we can have it like this. And inside we place the arrows end to end. That means which is passing through the center. That means it is arrows are ending at opposite ends of this diameter in this circle, and that diameter we have extended and taken like this. And here we can write, say its diameter is 20 mm, so we can write 520. 5 represents diameter, and mm, say diameter of this is 20. Now from that, this particular line is leader or pointer line. So this is used for this kind of dimension. So another type, another also I can mention. Radius wise also we can mention it. Radius wise also we can mention it. Same hole. Same hole. From the center, draw a straight line and draw like this. There, only one edge, like a ray. From center, you draw a ray. I mean arrowhead on one of the points, one side of it. They extend it like this. So here we can draw R. Say it is 20 mm diameter, so radius will be 10 mm. So pointer or leader lines are used for supporting this dimension, to extend it out of this object and write the dimension there. Because writing the dimension inside would be clumsy. So it will be helpful in such situations. Now short break line and long break line, they have some certain thing we need to discuss. Now say there is a very long rod and we are interested to study only this part. We are not interested to study the whole part. We are interested to study this part. And we are taking this, we will draw it something like this. With waviness at these edges, taking this part out. This waviness represents that there is some part that side and there is some part this side. Say for example, I am drawing a straight line here without any waviness. That means this is it. This is the end this side. But that side, this is wave. That means there is some material other side. We have broken it from there. And we are studying only this part. We are neglecting that part. That is what it represents. So that is why we need waviness. So here, since there is a total length and we are taking this part, this side also we need to keep waviness. This is called, this wave line, we call it as short break lines. They are short, right? Now long break lines. Say in diagrams, say this is some 200 centimeters, that means 2000 mm, very long. In the drawing sheet, we don't want to waste that much of space. What we can do, the end line, we can have some waves intermittently. So it will be straight line, but intermittently here and here we have waves, wavy structure with a peak and a trough. Bottom also we can do the same. That means that This total thing is actually 2000 mm. We can write the same here also. Total is 2000 mm. But you will be wondering, here 2000 mm represent this much length and here this much. Why? Because this part, when I am breaking it here like this, I am reducing them. That means this is a broken part. Actually, it is not this much. This part, this portion is actually of more length. That I am representing it by this wave at the ends. This original part will be something like this much length. So that I am representing in this way. The remaining part as it is outside it. So within this, I am reducing the length. Actually, this length was this much. I am reducing it and writing like this, representing like this, reducing the length. So for a long edge, I am reducing it to short edge using this with little breaks here. That means this line, we call it as a long break line, which is representing a long edge as a short edge. Now, next one, hidden or dotted lines. I have already explained you that, say this is a cuboid. These are edges visible. Now there are certain edges that are not visible, which are behind the scene. These are the front edges, on front line edges, which are visible to us. Behind that, the backside edges are not visible. Those lines we draw as dashes, intermittent lines, not continuous. Those dashed lines we call hidden lines or dotted lines because they represent hidden edges or inferior layers. The superior layers is those which are in front. Inferior are those which are behind them, which we can't see. Center line. Now center lines, say this is a cylindrical part. Now we want to represent certain center. The cylinder will have certain center. And we know center will be joining the centers of the end circles. Now how to represent center line? We will have a dash and a dot. Again a dashed line, again a dot. Dashed line, again a dot. Like that. So this represents a straight line with a dot in between, again a straight line with a dot in between. And this intermittently dashes and dots compose a center line. Okay, so let's get to the next few types of lines. So coming to the next set of lines, that is one is cutting plane lines, chain thick lines, chain thin double dots. Say come to cutting plane lines. Say we have a certain element or component like this. Just for explanation purpose I have drawn it is not a perfect one. And certain this hole or a blank. Now I want to draw when I look from this side. When I look from this side, I will get it like this. Right? Front. This is isometric view, say for example, for suppose. Now when I have a front view, actually this from this side, I will have this. Now for this there will be dimensions, of course. Those are things, okay, I am not going into the details. Now what I want to do is, I want to break this part and study these sections, how these sections are. Now when I want to do that, I already said, when I break it, it will be something like this. And I want to study the upper part. It will be something like this. Now, this inner one is a curve actually, representing this. And now these are sections. Because the material here, this is hollow. This part is hollow. That's why I have kept it as it is. But in this part, this total thing is filled with material. So wherever there is material, it should be represented by section like that, because of cutting them. But when I am having section, that means I am sectioning it or cutting it somewhere. And to represent that position, I should use the section line or cutting plane line. Sorry, cutting plane line, not section line. Cutting plane line. You might be wondering, this is same as center line, but there is difference. Center line uses dots and thin lines, but this cutting plane line, it will be thin lines and a dot inside, but at the ends it will be thick. At the ends it will be thick. In between it will be thin lines and dots. At the ends, only at the ends it will be thick dashes and dots. So this is continuous line. This is, we can call it a thin line. Thin, first thick at the ends and thin end in between. This we use for cutting plane lines. Now chain thick. Say for example, this surface I want a special treatment, and I will specify what is that special treatment. So in front view, this total surface is represented by this line, right? On that line, chain thick line means this one. That means everything will be same dash and dots, but from front to last, beginning to end, all the total line will be thick dots and thick dashes. That we call chain thick. That represents special treatments, special surface treatments. Now chain thin double dots. What does that mean? What is it used for? Chain thin double dots are used for, say for suppose, I have certain component and it is actually a connecting rod. Initially it is here. Say for suppose it is a connecting rod. Initially it is here. At certain position it is rotating, and in that rotation it has become something like this. Right? Now anyway, this is circular part, so it will be same. This is rotating. Now actually these lines, so this is position 1. This is position 2. I want to represent motion of this object with respect to time. At time 1 it is here, at time 2 it is here. Then how to represent that motion? I will use chain thin double dots. That means these are represented not like this, but thin lines with double dots. Thin lines with double dots. Thin lines with double dots. Double dots. Thin line, double dot. Thin line, double dot. Same way here. Circle will also, this circle also will be thin line, double dots. Thin line, double dots. Thin line, double dots. Like that. That way we have to represent. So that a dash and 2 dots, dash and 2 dots, and all the dashes are thin. That we call it as chain thin double dots, which is used to represent 2 different positions with respect to time. So motion. This simply representing motion. So with this, we can end types of lines lecture. In the next lecture, we will discuss few things about lettering.